back in the way.
Actually, where are we?
Alright, projectile motion is what we were testing this week using the PhET website, which we have come to find out is not working today, but we will remedy that soon.
Magic of editing.
Yes, yes. So, what we measured basically was distance in respect to angle through this program. And we launched a human at different angles. Yeah, right. Our angles were 80 degrees, 60 degrees, 40 degrees, and 20 degrees. And we would kind of look at the distance in proportion to that angle. So, kind of what we were expecting, I guess, is what we can start off with.
We also had 3 different
Oh,
speeds.
yes. Thank you.
So, or velocities.
Mm-hmm.
6, 12,
18.
18.
Those numbers, 18 was just, if you switch whatever you're going to fire out on the simulator, it just magically gives you an initial velocity, and for some reason it decided humans get launched at 18 meters per second.
So yeah, I mean, what we expected, I expected to see a trend, you know, the lower angle, lower distance, but then again, if you have too big of an angle, then you have a lower distance as well. So yeah, I kind of expected to see that trend that we got on the graph.
We'll show in a minute.
Yeah.
Right. You see the nice little parabolic arc, and we could do whatever we wanted. We also see sort of what's expected is if you reduce the initial velocity, the distance sort of does not go as far. And there also seems to be both, we also find sort of like an optimal angle of firing, as well as sort of, that's more an optical angle.
Mm-hmm.
Yeah.
Exactly. Okay. And yeah, just to chime in, I agree with all those points. Same thing. I knew that, you know, the higher angle, it's going to get great height, but it's not going to get that distance. So, but same thing, once you go down that 20-degree angle, you're just not going to have the oomph to make the distance either, so you need something in between. Okay, so, next thing, what happened? It kind of was aligned with our expectations, for the most part, I think.
Yeah, for the most part. I think the surprising thing is we tried just to see what would happen if you had no initial velocity, what would happen. And for projectile motion, it seems to be initial velocity is probably even more important than angle, because it didn't go anywhere.
Yeah. I guess I really didn't think ahead on that one. I mean, when we did it,
Yeah, just like, I
It
wasn't
just-
even...
Yeah.
didn't really happen. Okay, any difficulties that we had with this one? Obviously what we're having today, but
Yeah.
will be remedied soon. The actual,
While doing it.
yeah, while doing it, it seemed to work
I think,
pretty well.
yeah,
That's kind of the beauty of a simulator.
simulator,
Yeah.
but also I think the part was, I think, don't have it quite yet in my mind. But I think the difficulty for us was the disconnect between how to get them to intercept, and then, I mean, we can show that on the graph by basically, if you take a horizontal line at a given distance, that's where they're going to intercept. The line that crosses two different initial velocities, that's the one that's going to intersect at that, and then it's just a matter of offsetting the time and everything else. I also think another thing was, because you have a simulator, you have so much you can do. I mean, we literally played naked graph where we started going, let's put angle down here, distance over here, initial velocity, and just saw something that we could actually figure out, that we could actually talk about.
Yeah.
And that's what was nice. I mean, we saw some of our fellow classmates who were trying to work the whole gun experiment again with the Nerf guns, and it did look like a struggle. I mean, that's how we learn. But to really get that visual, I'm a very visual person, obviously, and to see the simulator work and actually see how everything is calculated really helped make sense to me of what we were doing.
The other thing is, about inquiry is, like in a classroom setting, and I mean you can do this at all levels.
Mm-hmm.
You can do this. You can use this one as incredibly guided or incredibly open, and you can literally say, U group work with angles, U group initial velocities, U group. One thing we didn't play with, but we found out later, is that you can adjust the height.
Mm-hmm. Yeah.
You guys play with the height, so you can have different people doing different things, and they can basically say, this was important, that was important, and it'll be done in a fairly quick time, because it only took us 10 minutes maybe
Yeah.
Yeah.
to do everything, and then you can literally come back together and say, all right, was this important? Yeah, no, and then, okay, there's still going to be some kids who don't believe it. Let them go, do it, and so basically you've still got half your class left by the time they go and do the one they don't necessarily understand.
Mm-hmm.
Yeah, very useful in any classroom. I mean, elementary, I don't think they'll be doing a whole lot at this level, but it's something that they could at least play around with and get an introduction to the whole idea. And I guess our relationships is our last topic. Kind of talked about that. I mean, if we're talking about relationship between distance and angle.
Yeah, so we might as well pause this for a moment
Alright.
while we flip it around. Okay. So this is the relationship we've finally settled on. You'll see that we have 3 velocities, initial velocities I should say, with the 18 meters per second being the blue line, and the 6 being the green, and you sort of see a trend where they sort of peak out around 45 degrees, and that's sort of where we came up with the idea of optimal angle. One thing we sort of, by looking at this, wanted to go back and do is add 0, but haven't had any luck getting into the simulator, so we might take a quick snap of that a little bit later to show if it originates from 0 up on the axis, or maybe actually at the original origin point of 0, 0. You don't need to say it, but it's pretty much, because you'd fire something straight up and down, it would all converge back again on 90 degrees. And as I said, if you were to take a horizontal line and draw it across, and if it crossed both, let's say the blue and the red, you would have some place where an intersection would occur. So if you fired them at different times or figured out the timing, you could actually have the little interceptor that we tried to do in the guided inquiry. And through the magic of editing and network administrators fixing their problems, we were able to say it starts from basically an elevated point.